All right, time to get started. So welcome to third lecture. So what we're going to do starting for the next few weeks is we're going to start the first module of this course. And we're going to look at how to explore data sets, how to visualize, how to look for patterns, how to look for trends. To do that, we're going to rely on the computer to do a lot of that work for us. So to enable a lot of the stuff we're going to do later in this course, you're going to need to know some computer programming. So the very first thing we're going to teach you in this course is we're going to teach you a little bit of coding in a programming language called Python. So that's what we'll be doing for about the next 2 weeks or so. I wanted to let you know up front because it's going to be pretty technical and there's a lot of little nitty gritty coding stuff. And I want you to not worry. The whole class is not like this. So there's some of this that we got to get out of the way first, and that's going to enable us then for the rest of the class to do a lot of the conceptual and data science stuff. Okay, so just fair warning. Okay, so the goals for this week, we're going to start teaching you about Python, which is a programming language that lets you write code and manipulate data. We're going to teach about tables, which is a way we're suggesting for organizing your data. And then on Wednesday, you'll talk about different kinds of data that you can manipulate in Python. You'll talk about arrays, which is a way to handle a large stream of data. And we'll talk on Friday about how to write code to create tables and manipulate the data in the tables and get started with some of the operations on tables that are going to be useful for you. So some announcements. First discussion sections start this week. So today, tomorrow, and Wednesday. Please go to your discussion section if you're enrolled and not on the wait list. Attendance is mandatory. Be 30-minute discussion section intended to try to encourage interaction. So there'll be just 6 of you. I hope you can help us make it a success. So we'd love you to participate in discussion sections. Even if you say something that's not quite right, that's okay. It's okay if you say something stupid. Part of learning is we try to ramp up the level of difficulty so you can't get it on the first try, and sometimes we make mistakes, and that's all right. And I also want to set the norm for discussion sections that I hope we'll all go video on so that you can facilitate the sense of being there together. I know it's not the same as being there in person, but you will have a TA who's leading the discussion. You'll have a worksheet that you'll work through problems together, and then you'll come together as a group to discuss how to approach them. So it's a chance to practice and work with some of the conceptual materials. No need to prepare in advance. For this lecture, you can find slides and the demos online on the course website. Okay. So side note, we were talking last time about correlations and causality, and here's a fun example of a spurious correlation, an association that probably is not causal. You can see here graphed divorce rates and consumption of margarine, and I don't think those two are causally related in any way. This is taken from a website that you can find a link to that has a whole gallery of these kinds of bogus correlations. I just think it's fun. All right, so Python. You started to get in lab 1 a little bit of exposure to Python. So let me just talk you through some real basics about coding in Python. Coding is not the main focus of this class, but you're going to need to know a little bit because it's what's going to save us from doing things tediously by hand. In the old days, 100 years ago, statisticians used to work with data sets by having it written down on pencil and paper, and any kind of computation they wanted to do, they did it by hand. They would laboriously write out these figures. And that meant it was super tedious and that they were limited to reasonably small data sets that they could work with. And what computing opens us up to is it takes away the tedium and it enables us to work with much larger data sets, which is much more powerful, lets us find a lot more interesting phenomena in the real world. That's not what I wanted to do. There we go. Okay, There are multiple programming languages out there. Python is one of the two main languages, is probably among the most popular for data science in industry. Python is also one of the popular languages for general software development. So if you've ever wanted to learn just a little bit of programming, you'll get a little bit of that from this class. Mastering how to write code is going to be fundamental for this class because we're going to use it throughout the class. And the way you learn is not by watching. It's through practice. It's a little bit painful. The computer is extremely unforgiving. I guarantee you will make mistakes in your code, and any human would know what you're talking about, and the computer is going to be like, nope, not doing that. And it's going to be frustrating. The computer is going to give you error messages. They're going to be hard to figure out. And the way we deal with this is just through practice. We get better at it through practice. So be prepared for that. Don't get too hard on yourself if it happens. Ask for help if you need it. We can help you out. If you want to follow along with the Python demos that I do, you can find them linked to on the course webpage. Okay, so let's do our first demo. Let's see. So here's our familiar notebook. And notebooks are a way of organizing data and notes to yourself and code. And so up here, you can see this is a Python. Each one of these gray cells is a Python cell where you can write code. And we put some boilerplate at the top. You will need to always run this topmost cell. Don't worry about what it does. It just sets up the environment we're going to use for working with Python. Okay, so if you don't run that topmost cell, you're going to get weird errors. If you leave your notebook open for a while and then you come back a lot later, or you save it and close it and reopen it, the environment, our servers, might forget the work you've done before. So if that happens, what you can do is you can just restart the kernel, and then that will clear everything out. And then you can start over from scratch and you can run from the top on down. Okay. I apologize for everyone if you're having troubles with the getting onto Data Hub to do the live lecture. What I've been investigating, the server issues, and what I've learned is our servers gradually scale up. So if 1,000 people all log on at the same time, the servers have to go from 0 to 1,000, and it takes them about 10 minutes to do that. So hopefully it will catch up with you if you keep trying every couple of minutes. Okay, so let me just give you a little examples of some stuff you could do in Python. One kind of thing that you can manipulate in Python is you can manipulate numbers. So for instance, there's a number. You can do arithmetic. You can use it like a calculator, like this. You can do division, and you'll see that it gives you the result. So that in each case, the result is showing up below the cell. So the cell here shows you the Python code that you type in. And then when I click run on that cell, it runs that Python code, executes it. That code produces a result, and then it displays to you the result. Do I need a space between the operator? Nope. And questions like this, by the way, you're welcome to check out when you get access to the demos. You can open up the notebook and modify it and play around with it and try some examples yourself. So let's try it and see what happens. No problem, no space needed. So the space was just there for me to make it look nicer and help my understanding, and it's a matter of style whether you put the spaces or not. You won't need this exact notebook. If you click demos on the course website, it'll take you to LEC03 notebook, and this is just my own personal slight modification where I've deleted a bunch of stuff, and so I type it in by hand, and you can see as I enter it in as I go along. This kernel restart and clear all won't erase your previous work. It won't erase any of your code. It just clears out the output, and then you can rerun the cells and see the output again. Okay, so you can also do more complicated expressions. For instance, here's an expression. Let's see if we can predict what that's going to produce. Anyone want to type in chat what you think the result of that's going to be? Nice, nice. I got lots of answers here. And for everyone who said 45, I am super sympathetic, because that's what any human would, probably many humans would look at that and would say. It'd say 2 plus 3 is 5, and multiply that by 9, that's 45. But it's not how Python actually interprets things. What Python does is it says, oh, I'm not sure whether you wanted me to add first or multiply first. And when it's not sure, it has some default rules. And in this case, the default rules are called precedence rules. You don't need to memorize this. Said multiply first. So whenever you've got multiple operators like this, it's good to tell Python explicitly what you had in mind. And the way you do that is with parentheses. So you can say 2 plus 3 times 9. And what that will do is that will tell Python, first interpret the stuff in parentheses, and then multiply that by 9. And if we wanted to multiply 3 times 9 and add 2, we could put the parentheses like this. Another operator is if you want to raise to a power, 2 to the 4th power, meaning multiply 2 by itself 4 times, you do that with a double star operator. And that will give you 16, as you can see. That's how you work with numbers. You can also work with strings. A string is just a bunch of text. And in Python, the way you indicate that to Python is you put a quote around it. Okay, so you put a quote at the beginning and a quote at the end. You can use either a single quote or a double quote. Just use the same consistently. Okay. So that's Python. That's how you can write very simple expressions that let you calculate simple stuff with numbers. Anytime you start to do a little bit more complicated computation, you'll probably discover that it gets a little painful to write in all the numbers. And it turns out it is useful to have the notion of names and assignment statements. And a name is a slot where you can put in a number or a string. Okay, so assignment statement associates a number or something like that with a name. So if we have an assignment statement here on the left, hours per week equals 24 times 7. What that's doing is it's introducing the name hours per week. The equals is Python's way of indicating this is an assignment statement. Python will take that stuff on the right-hand side, 24 times 7, and it'll say, that's an expression, I know how to evaluate that. And the result will be 24 times 7, 168. Okay? So the first thing Python's going to do is going to say 24 times 7, what is that? That's 168. And then it'll say, oh, I see this is an assignment statement. So let me introduce the name hours per week. And let me associate the value 168 with that name. So if you ever use that name again, Python will remember that value and will use the value that you most recently assigned to that name. Okay? So this is kind of handy because it's a way to have Python remember things for us. And it's a way to give names to the things that we're constructing or computing. Okay. You can recognize an assignment statement because there's an equals sign. Now, this thing on the right is called an expression. An expression is any of that calculator-like stuff we were doing that produces a value. A value is like a number or a string. Okay, so you can recognize assignment statement because it has an equal sign and the left is the name, on the right can be any expression you want. If you type an expression into a Python code cell, Python will evaluate it and show you the result of the expression, but the expression doesn't actually do anything. It doesn't actually change anything for the future. It just shows you the result of evaluating that expression. Assignment statements do something. They change the situation for the future. Now this name exists and is associated with the 168 and will be from here on in until you change it. So they have an effect that has some lasting effect beyond the current cell. They don't result in a value. So if you type this into a code cell, you won't see any output, but it will have the effect that the Python now remembers that name, and any subsequent code cells, it'll now have some meaning for that name. Okay, so let's look through some examples. Let's do some examples with names so you can see how this works. I can introduce a name like 4. This will introduce a name and associate the value 4 with it. Notice how there was no output displayed here because this wasn't an expression. It didn't have any, produce any value. It just was useful to request Python to remember this name. Now in the future, in a later code cell, if I want to ask Python to please recall that thing associated with the name A, I can do that, and Python remembers what was associated with A. I can also use A inside an expression. So I can write something like this. What that will do is it will look up the value of A and plug that in. So it plugs in a 4, and then it says, I see you're trying to compute 4 times 2 and evaluates that expression. Okay. So we can introduce new names and see what their values are. We can compute with the names. That was 4 plus 9. We could give a name to that and look at the value of that name, 13. Okay, all good. And notice that a name is different from a string. Okay, so if you have some word like this, that's a name if it's not in quotes. If you wanted a string, you put it in quotes, and now it's not interpreted as a name anymore. It's just some text that Python doesn't assign any meaning to. Can you do B times A? Absolutely, you can do that. You need to make sure that you have you have defined both of these variables. You've assigned to A and you've assigned to B, and as long as you've done that, it will enable you to use it. Now, if you have a variable that you forgot to assign to, let's say we do C times A. Let's look at what happens. Error, name error. It tells us the name C is not defined. And that's because we didn't have any assignment statement that introduced the name C and associated it with a value. So Python says something's wrong here. So you may get these error messages a lot. And let me tell you how to read error messages like this. This is, you're going to see here, there's an error. Sometimes there's like a name with a type of error. Sometimes that's helpful in giving you a clue what's going on. Name error indicates some problem with one of the names. Usually start by reading the last line of the error first. It's a little counterintuitive, but you go to the end of the book and you read the final line. And this one will tell you the name C is not defined. So this error hopefully was actually pretty useful. Sometimes errors are not very useful. So we do our best. All right, so that's names. One note is this might look like an equation, but it's not like a mathematical equation. It's not like asserting that these two are equal. And let me indicate for you how it's not like an equation. Remember how we noticed that A was assigned to a value 4? Well, I can reassign to A. It could be a little confusing, but I can do it. Now, if I look at the value of A is 7. So even though I had A assigned A to 4 up here, that's not saying A will always be 4. The value of A might change in the future. So it's not quite like a mathematical equation, even though Python writes it in a way that looks like one, which could be a little misleading. All right, next topic. I want to teach you about functions in Python. Functions are useful when you have some task that you want to do over and over again. Sometimes someone has written some code for you to do the task that you want to do. Then usually they'll provide it as a function. And this is a way that you can invoke the code someone else wrote. Sometimes those are called library functions. Okay, so a function is something that refers to a bunch of code that can be used over and over again. Anytime when you want to use that code, we say that you call the function. The mental model, if you like, is I'm picking up a telephone to a friend and I'm calling the friend and I'm saying, hey, can you help me do this calculation on the number 27? And your friend does all that work and then says, yeah, the answer is 54. Okay, so your friend is a Python function in that example. Okay, so the calling means to use a function. And the way you do that in Python is you write something that looks like this. Here we have f is the name of the function. 27 is that value that I want to provide to the function. So I'm going to ask the function to execute its code, and I'm going to give it a value and say, please do something with this number 27. And the function does something. Each function will do something different. These parentheses are used to mark what is the value that is being provided to the function f. So we say that we call f and we pass it the argument 27. So this 27 may be called an argument or a parameter. We're passing it the argument or the parameter. Okay. So you can see here before the parentheses is the name of the function to call. That's just a name. It doesn't refer to a number. It doesn't refer to text. It refers to code. It's called a function. And inside the parentheses is the argument. That's what we want the function to do something with. Okay, so you might say call f on 27. Here's another example of using a function. This time we're using a function called max. You can see that because it's before the parentheses. You can tell it's a function, invoking a function because there's a name and then there's these parentheses. And in this case, if we look at what the argument is, what the parameter is, well, actually there's two of them. So you can supply more than one number or more than one thing to a function. You just need to separate them by commas. The comma indicates to Python, I've got multiple things for this function, and I will separate them with a comma. So here we are calling max on the two numbers, 15 and 27. And max is a function that is provided for you as part of code that's already present and given to you by the Python programming language. And what max does is pretty intuitive, is it takes the larger of those two numbers and we say that it returns that to you. So the result of evaluating this expression will be 27. Okay. So let's look at a demo. All right. I skipped something there. Well, let's do our demo with functions, and then I'll come back to what I forgot that I wanted to do and I skipped. All right, so here's an example of a function call using a function. In this case, the name of the function is ABS, abs. And that might look mysterious what that refers to, but it's shorthand. It indicates that this is the absolute value function. This is also provided by the Python programming language. And let's see what happens if we run it. We called abs on -5, and it gave us back, it returned the number 5. So what it's doing is computing the absolute value of the number that we give to it, of the argument. If we called abs on 5, The result will also be 5. Either way, it's giving us the absolute value. So minus 5 is the argument or the parameter. So far, I'm only talking about how to use functions that someone else has written and provided to you. In a week or two, we'll teach you how to define your own functions. For instance, if you want to write some code that you'll give to someone else, or if you want to write some code that you're going to use over and over again. But for now, we're going to stick to ones that are made available to you, and we've made available a lot to you. So that'll help you out rather than having to write complicated code yourself. Often you can just reuse something that we wrote for you. All right, so you can see that abs will do the same thing every time. It's computing an absolute value, but it's different what it's computing the absolute value of each time. That's why we have these arguments, because they allow us to indicate the data that we want it to work with. Abs is the function, yes. Now, you don't have to give abs a number. You can provide an expression that evaluates to a number, and Python will evaluate that expression before calling abs or calling any function. In this case, it evaluates the expression 1 minus 3, and it gets the result is minus 2. Then we call abs with the argument minus 2, and abs computes the absolute value of minus 2 and returns to us the result, which is 2. Okay. So here's a little bit more interesting example. We'll assign some names, and then we have an expression here which Python will evaluate for us by plugging in the values of those names, taking the difference, and then passing that argument to abs. So if we look through the code, night temp was assigned to 47, day temp was assigned to 52, so we got 47 minus 52, that's minus 5, and we call abs on minus 5, and it should give us back 5. Okay, so this is the kind of code you might write if you wanted to compute what the difference between the daytime and nighttime temperature was, but you didn't really care whether nighttime was cooler or warmer than the daytime. I mean, it's usually going to be cooler, so we just wanted to know the gap, and we didn't want to be bothered by a minus sign. Here's another example of some code you can write. Another function that's provided for you is the min function. It's a lot like max, but it returns the smaller of the two numbers. We also have a round function. This round function will take a number that has stuff after the decimal point and round it to the nearest integer. Now, what if you didn't want to round to the nearest integer, but you wanted to keep one figure after the decimal place? Well, then you can pass a second argument to the function round. Round will optionally accept 2 arguments, where the first argument is the number you want to round, and the second argument is how many digits to keep after the decimal place. Okay, so this is what it looks like if you want to call a function with 2 arguments. All right, you could do it with, if you wanted to keep 2 decimal places, you'd look like this. I don't care too much that you memorize the round function. I just wanted to demonstrate what it looks like when you have functions that have multiple arguments. And that some functions may take a variable number of arguments. So what's going on with round is round has a default value. If you don't provide the second argument, it defaults to 0. Okay, so this providing 0 gives you the same answer as not providing anything else because it has a default. And in this case, well, Python supports another way of calling functions, which I haven't shown you yet. You can, the function can provide names to its arguments. So in this case, the round function will accept an argument that is named n digits. N digits is supposed to remind you that this argument indicates the number of digits to keep after the decimal place. So you can also call a function like this. And if you ever see a function call like that, where you have what looks like an assignment in here, it's not really an assignment. It's not creating a new name. What it is that's called a named argument. functions can provide named arguments. They're kind of handy because it might be hard to remember when you look at an expression like this. What does that one refer to? I can't remember. So by using named arguments, anyone who looks at this code, there'll be a little reminder to you or anyone else. Oh, that one is a number of digits after the decimal place. So it helps you write code that is a little bit clearer to you and others, and that'll help you avoid mistakes. Yeah, let's look what happens. Is n digits a new name that got defined and assigned here? No. So it looks like we're assigning a name, and I know it's a little confusing, but it didn't really create a new name. If you wanted, you could sort of think of it like there's a name here that's only in place while the round function is executing, but not after it finishes. But maybe it's easier to think of this as a named argument. Okay. All right. Questions on functions? What's the difference between assignments and arguments? Assignment is when I want to create a name that I'm going to use again in my own code. An argument is when I want to call a function and give it some data to work with. So the argument is associated only with this call to the function. And it's only around while that function is working on the thing I asked it to work on. And then once the function finishes, that argument kind of evaporates and disappears and is no longer remembered. Whereas names are remembered forever. Are there any other important functions? A bunch. And we'll teach you them gradually as we teach you how to do various data science operations. We'll teach you some functions that are useful for doing them. So I don't want to overload you today and try to go through everything today, but you'll learn a little bit in each lecture over the next few weeks. Why would I want to use this instead of this? It's a matter of style and personal preference. The reason why I like this is it's not unusual that I write code today and then I set it down and next week I come back to it and I want to do some more work. And I look at the code and I want to try to understand what was I thinking a week ago? What does that code do? What is it trying to accomplish? And what I find is that if I write code that looks like this, it's easier for me to understand what's going on. Whereas when I write code like this, I might not remember what I had in mind because I don't memorize what the meaning of all the arguments to every function that's provided in Python is. Like if you asked me today, I could tell you what the second argument to round is because I looked it up before lecture. But if you quiz me on it 2 weeks from now, I'll probably have forgotten. So this is a little reminder to myself that isn't necessary for the computer. It's just for the sake of my own clarity. Are named arguments specific to a particular function? Yes, they are. Could I give an example of f of 27? Well, this round is an example. Here instead of f, I have round. Round is the name of the function. Yeah, so the f of 27 is sort of like an example if f was the name of your function, but different functions will have different names. So your function might be named round or max or min, and instead of an f, you'll have whatever the actual name of the function is. We'll test you on some things about coding, but primarily the course is focused on concepts and techniques where you'll use the coding rather than to accomplish something. So it's not about coding for its own sake. It's because we want to analyze data and draw some conclusions around the world. And the coding will be helpful with that. Can round work on integers? Sure, let's try it. Ta-da! They can work on integers too. Okay, don't worry about how to define your own functions. We'll get to that later. So actually, let me come back to something that I wanted to do and I forgot to do, and I just scrolled right past. I wanted to talk about names too. So let me go back to names. And I wanted to talk about why we use names. It seems, at first thought, it might seem unnecessary. And indeed, names are, for a lot of purposes, unnecessary. Instead of introducing a name for a number, you could just write down the number. But I want to give you some intuition for why it's often really good practice to name each of the things that you compute in Python. So let's go through some examples here. I'm going to write some code. For instance, let's say I wanted to compute, if you have a full-time job, how many hours you're working in a year. Okay. Well, I want to suggest that a reasonable way to do that, a nice way to do that, would be to write down some names, a name for the number of hours per week, a name for the number of weeks per year, and then we know the number of hours per year should be obtained by multiplying those two. All right. Oops, what was the answer? It didn't show me. That was an assignment statement, not an expression. It doesn't have a result, so it doesn't show me anything. If I wanted to see what just got assigned to that variable, I have to type it in an expression and ask the notebook to show me. And the answer is 2080, so about 2,000 hours in a year if you're working full time. Now, suppose I wanted to use that to figure out how someone who is earning the minimum wage in California, how much they'll earn as an annual salary. Okay, so we first look up what the hourly minimum wage is, and in California, that's $13 an hour. And then what we're going to do is we're going to try to compute we could compute the amount that this person might make per week or the amount they might make per year. So the way we could figure out how much they'd make per week is multiply that wage, $13 an hour, times the number of hours in a week. And it doesn't show me the result of that. So if I want to see what value got assigned to that variable, I need to put it in a cell. And the answer is a minimum wage worker earns $500, about $500 a week. Not very much. And if you want to see how much they earn in a year, do the same computation, but now we used hours per year. The answer is minimum wage, full-time job earns you about $27,000 a year. Not very much, pretty challenging to get by on that. Okay, so you'll notice that this computation before tax, yeah. You'll notice that I could have done this entire computation just using Python as a calculator without using any names, right? I could have gotten the weekly wages by computing 40 hours per week times $13 an hour. And I would have gotten the same answer, 520. And I could have computed the yearly wages by computing 52 weeks in a year, 40 hours in a week, multiply that by $13 an hour, and I would have gotten the same answer. Okay, so I didn't have to use names here. But I think for many computations, it's nicer to write your code using these names. Which would you, if you're looking at a notebook someone else wrote, rather look at? Would you rather look at 52 times 40 times 13 and try to understand what on earth that represents? Or would you rather look at something that said hours per week is 40, weeks per year is 52, hours per year is such and such, California minimum wage is $13, here's what the yearly wages are. What that's doing is it's walking you through the process of obtaining a result and documenting or describing for you the logic that was used and the reasoning that was used to get that. So you can check it for yourself and see why it makes sense. So I think it's good practice to write your code in a way like this so that it's apparent to the reader what the code is doing, where it came from, why it's right, what these values mean. When you have a value, what's the interpretation? This is a number in dollars that's a yearly wage. Okay, so good practice, good practice. That's why we introduce names. One reason. How did I decide to break up the lines into separate cells? I could have put them all in one cell. I could have put them into separate separate cells, and it doesn't really matter for purposes of the Python. The only reason I put things in separate cells was because sometimes I wanted to see what the result of evaluating expression was, and Python and Notebook will only show me the last expression in a cell. So you can put multiple lines in one cell, and it's kind of the same as putting each line in its own cell, except it'll only show you the last thing. You don't have to print. If you have previous experience with Python, you might be familiar with printing an expression using the print function to display something to you. In Python, in the notebooks essentially auto print the last expression in every cell. So you don't have to explicitly write print. Okay, let's talk about tables. We're going to organize data in tables. And a table is kind of like a spreadsheet, but it's one that we can manipulate with our code. So let me be a little more specific by that. A table is like this two-dimensional thing with rows and columns, and each column is labeled. And the idea is that each row is going to represent one individual, like a person who's participating in an experiment, or a state, if you're measuring something about states, or a city, or a car, or something like that. And each column represents one attribute of the individual. Like if each row is a person, maybe you have a column for their height, another for their weight, and another for whether they smoke or not, and another for their name. Okay. If each row is a state, then you might get a table that looks something like this. The top of each column has a label associated with it, which will usually display at the top of the column. It's not part of the data in the table itself. It's a label to help us interpret the meaning of the things in that column. So then each state has a name, it has a 2-letter code, and it has an area. All right, so a column is the vertical stuff, a row is the horizontal stuff. And we're going to organize all of our data using tables. It gives us a nice structured way to keep track of our data. So let me give you some examples of tables and how you manipulate them in code. And we'll be looking at how to do a lot of the stuff we do by working on it, putting our data in a table and then operating on it as a table. So, oh, yeah. Okay, slight error on my part. Brief moment here while I fix it. Okay, enough of that. And we're back. Sorry about that. That was an error on my part. All right, so here we have Python code that's going to load a table. It's going to load a table into the computing environment. And then this is loaded from a file. You can load any spreadsheet. If you save the spreadsheet as a CSV file, that's a standard format, then you can load that into the notebook. And the way you do that is we're using this function called table.readTable. And the argument is the file name. We have to put it in quotes because it's a string, it's text. When you do that, it creates a table. We assign the name cones, and cones now refers to this table. And this is just a very simple example of a table. It's a trivial table that represents a few different kinds of flavors of ice cream cones you could get. Now, there's a bunch of operations you can do on tables. One of those is that you can show some of the data. For instance, if I want to see just the first 3 rows, I can do an operation called the show operation. Maybe there's thousands of rows in some tables and I only want to see a few of them. So this is an operation. This is a function call right here. It's a function call. You can see that because there's a parentheses. The argument is 3, indicating that I want to see the first 3 rows. And it's a funny kind of function call. Sometimes I call it a method, but you don't need to know that. The operation, it's an operating on a thing, on a table. So here the name of the operation or the function is show, and it's applied to the table that's associated with the name cones. Okay. And I can use this show operation on a table, on the cones table. And if I don't pass any arguments, then it'll show me all the data. There are a bunch of operations you can do on tables, a bunch of functions that we provide for you that will do stuff with tables. For instance, one thing you can do is the select operation, which picks out just a single column from the table. In this case, we picked out the flavor column. And that creates a new table that has just one column, just that one column. Why might I do that if there's only some of the columns that I care about and others I don't? Then it might be handy to select just the ones I care about so I get a smaller table that's easier to work with. I could select more than one column. Here I've selected 2 columns that I care about, just the flavor and the price, and I don't really care about the color. Notice that these labels, you have to put them in quotes because they're strings. If you write without the quotes, you're going to get an error like this. So if you get an error, you'll know what's going on. Python is trying to interpret this as a name, but there's no name that I've assigned to called flavor. So Python says, oh, I don't know what's going on here. What you got to do is Python, as far as Python is concerned, these are just strings, and Python doesn't care what the meaning is. The meaning is assigned by this select operation. So you got to put this in quotes to indicate to Python that's just a string. Then call the select operation. The select operation will interpret it. All right. Another operation you could do is drop. If there's a column you don't want, instead of selecting the ones you do want, you can drop the ones you don't want. And that creates a new table that does not have the thing you don't want, the price, the original ones. I want to point out that all these operations leave the original table unchanged. And most operations I show you are going to leave the original table unchanged. They just create a new table you can work with. So if you want to do something with that new table, you may have to save it somewhere. And the way you save it is you use an assignment. You select a name, a new name for this new table. You assign it to the result of this operation, and then you can look at that name to see the result. One more operation that's really useful is the where operation. Select lets you pick out some of the columns. Where will let you pick out some of the rows. And the where operation takes 2 arguments. The first specifies a column. It's a label of a column. And the second one specifies a value for that column, for that attribute. So this where operation here is going to scan through the table and keep all of the rows where the flavor column has the value chocolate in it. And it's going to create a new table with just those rows. And here you can see that it's now a subset of the original table with just the rows where in the flavor column we had chocolate. So that's going to be really useful to pick out some of the data. Yet another operation you could do, the sort operation. Sort will reorder the rows, and you indicate which column you want to use to choose the order. So we'll sort them so that in this case, the price column goes from the smallest to the largest value. Now, you can choose whether you want it to go largest to smallest or smallest to largest by providing this descending argument. Okay, so the descending argument, if you set descending to true, then it will go from largest to smallest. If you set descending to false, then it will go smallest to largest. And that's the default, smallest to largest is the default. So this would be an example of a named argument you can see right here. Another operation is sorting. You can, here's another example of sorting, but now instead of on a number, we're going to sort on the flavor. The flavor is a string. So you see it sorts using that text. How do you sort with text? Well, it's going to use dictionary order. We said descending equals true, so that'll be from the end of the dictionary to the start. There will give you reference sheets that provide you a way to remember what all these operations are. I don't expect you to memorize it from just this demo. And you'll get a lot of practice, and that will help you remember all of these. So here's a brief summary of the operations we just showed you. I ran out of time to do another example with these, but maybe we'll do that next lecture, or you can check out the demos at the end on your own. So here's a summary of the table operations you learned. And in the coming lectures, you'll be learning additional things you can do with Python and additional operations on tables. Thank you, everyone, for coming to lecture today. Don't forget to go to discussion section and do the vitamin before next Wednesday. And on Wednesday, I'm handing off lecture to Professor Swapnil Sahai, who will be continuing to teach you on this subject. See you all then.